In this video, we're going to talk about entropy. Before we do that, let's recall Chapter 5 we discussed enthalpy, which is the sum of the total internal energy of a substance. When pressure is constant, the heat involved is equal to the change in enthalpy. Often in chemical reactions, a change in enthalpy is studied, and the symbol for this is H or delta H if we're looking at the change. Entropy is S or delta S if we're looking at the change in entropy. It is a measure of the disorder of a system or the surroundings. Low entropy is not preferred. So to look at entropy, we need to review the laws of thermodynamics. So the total energy of the universe is constant. The entropy, which is disorder, of the universe is increasing. Remember that if we have order, it's not preferred. For our first example of this, we can look at what happens when we have solid ice melting to liquid water and then condensing into water vapor gas. So this is what my solid would look like. I have a very rigid structure. Liquid, I would have more room, particles flowing past one another. And then in a gas, I would have even fewer molecules further apart. As we go towards a gas, my entropy will increase. In this example here, I can see that I have a hydrate molecule, so water is attached to my hydrate molecule, and I have a big complex molecule, ammonium nitrate. Now, when I react these two, I'm splitting into more particles. Entropy of a system will increase or become more disordered when there's an increase in number of particles in a system from reactants to products. So that's what happened here. We had an increase of entropy. Or if I just had this one molecule and it turned into Ba, barium hydroxide, and water got released, if I'm just decomposing, I'm turning into smaller molecules, that's also favorable. If the temperature in a system increases, that is favorable. Again, solid to liquid to gas, my entropy will increase. Or if I take a solid or liquid and I have a system of water and I dissolve that into a liquid solvent, now I'm dissolving my solid particles, that is something that would allow entropy to increase and I would create more disorder. This chapter we're going to talk about equilibrium and entropy. Note that the entropy of a system cannot increase forever and eventually a maximum state of disorder is reached. When this happens, the system appears to have constant properties, even though changes are still taking place at the molecular level. We say that a chemical system is at equilibrium when it has constant observable properties. Therefore, equilibrium occurs when the system has reached its maximum entropy. Try these examples on your own, and I'll make a video to explain each of them.